In 7.3, we're going to be looking at the unit circle. So our unit circle is going to be centered at the origin, and it's going to have a radius of 1. That's going to be a distinct characteristic of the unit circle. It'll always have a radius of 1. Okay? The angle in radians, theta, that intercepts forms an arc of length s. Okay, so remember our formula, s equals r times theta. Well, since r is just 1, really we just have s is equal to theta. Okay, so we have our central angle right here, and this angle is going to be directly related to this arc because they're equal since the unit circle has a radius of 1. So theta is really just our intercepted arc. Okay, now if we look at this, what we're trying to do is we're trying to get points on the unit circle, or we're using those to find out angles. Okay, so like sine of 0, we're trying to find out, well, what is that? Or sine of 60 or cosine of 60. We're trying to find points on this unit circle. Okay, so we have this point right here. We're just going to call it xy. We're just used to, on the rectangular coordinate system, we're used to calling a point on the coordinate system xy. So we're going to use the same terminology here, but we're going to tweak it here in just a minute. So if we have an angle right here, well then y is going to be the opposite side, x is going to be the adjacent side, and the hypotenuse is just going to be the radius r, or the radius of the circle. Okay, so say I do sine of theta. We know sine of theta is opposite over hypotenuse. Okay, so opposite is y and hypotenuse is r. But since r is 1 here in the unit circle, this is really sine of theta is equal to y over 1, which is just y. Okay, so this part right here, y, we can substitute that and say, well, hey, that's just sine of theta. Okay, if we take cosine of theta, we know that is adjacent over hypotenuse. Well, our adjacent side is x, our hypotenuse is r. Since we're in a unit circle, r is 1. So x over 1, that's just x. Okay, so here, x is just cosine of theta. So when we look for this point right here, we're not going to say, okay, that's point xy. We're going to say that is cosine theta, comma sine of theta when you're in the unit circle. Okay, so here's your facts. That's always true about the unit circle. S is always the same thing as theta because r, or radius, is 1. Your radius will always be 1 because you're in the unit circle. And the point x, comma y is really just cosine theta, comma sine theta. Every single time if you're talking about the unit circle. So we can find any point on this unit circle by using this right here. We'll find cosine of whatever the theta that you have. Say if we're over here, then our theta will start at the positive x-axis and go all the way to our terminal side, and we would find this point right here. Okay, now if we look at the unit circle and we use degrees, well, if you start out, you've got just 0 degrees, and then we go up to 90, and then 180, and 270, and finally go all the way around. That's going to be 360. Okay, so when we're at 0 or 360, at this point right here, that has the coordinates of 1, 0. So remember, this first point is always x, even though I just said it with the cosine of theta. Hang on for just a minute. It's x, comma, y. But look at this right here. This is really the radius, which that's going to be 1. Since we're technically on the x-axis, that means that y is going to be 0. Okay? And same thing if you just keep going around. This is your radius of 1. This is your radius of -1 since you're on the negative x-axis. And notice here that x is 0 because we're on the y-axis. Here, your radius of 1, or -1 since we're on the negative y-axis. And x is 0 because we're on the y-axis. Okay. Now you can do the same thing, just changing these from degrees to using a radius. Oh, no, sorry, not radius, radians. So if you start out, you're starting with 0 radians. Now notice this didn't have the little degree symbol, okay? So when I don't have the degree symbol, I know that I'm in radians. Okay, and then you go pi over 2, which is the same thing as 90. Pi is the same thing as 180. 3 pi over 2 is the same thing as 270. If I went all the way around the circle, well, now I'm back at 2 pi. And they would have the same ordered pair for each point there. The same thing as back over here. Same exact thing, because we're talking about the same points. Okay? Now this is going to help you with determining the sine of your trig functions. You notice here in the first quadrant it says all, and we're using the phrase all students take calculus to help us with this. So in the first quadrant, all 6 of your trig functions are going to be positive. So sine, cosine, tangent, and all the inverses are going to be positive in that quadrant. In quadrant 2, okay, students, that means take the first letter right there, so S, so sine and its reciprocal, cosine. Those two are going to be positive. The rest of them, of the trig functions, are going to be negative. Okay, and then take, so we're going to take t right there. So tangent and its reciprocal, cotangent, those are the only two that are positive in the third quadrant. The rest of the trig functions, the rest of the 4 are going to be negative in that quadrant. Okay, calculus, so take that c right there. So cosine and its reciprocal, secant, are the only two that are positive in that quadrant. The rest of the 4 will be negative. Okay, so all students take calculus. That's helping you determine, is my trig function going to be positive or negative within quadrant 1 through 4. It helps you navigate that. Okay, now let's find the exact value. So when it says exact value, it's talking about, it doesn't want decimals, it wants a fraction. That would be an exact value. Of sine of pi over 2, which we know pi over 2 is the same thing as 90. So we are at this point right here. And on the unit circle, we know that at that point of pi over 2, we have the order pair 0, 1. And because we are in the unit circle, we know that that point represents cosine of pi over 2, sine of pi over 2. So what we're looking for is sine of pi over 2. Okay, so sine of pi over 2 is the second coordinate in that ordered pair. So I'm going to look for the second coordinate in that ordered pair, so 1. So we know that sine of pi over 2 is the same thing as 1, and that's your final answer. Okay, so cosine of pi over 2, if we use the same logic, now I'm looking for the fourth coordinate in that ordered pair, so cosine of pi over 2, and same thing over here, so that's going to be 0. if we look at cosine of pi, okay, well, I need to go where pi is, which is right there. Right there. So it has the order pair of -1, 0. Since cosine of pi, comma sine of pi, since cosine of pi is first coordinate, I'm going to take that first coordinate in the other order pair. So cosine of pi is the same thing as -1. That's your answer. Okay, same thing. I'll look for the second one since I'm looking for sine of pi. Look for the second ordered pair or second coordinate in that ordered pair. That'd be 0. So sine of pi would be 0. Okay, sine of 3 pi over 2. Well, that's the same thing as 270 if you're talking about degrees. That order pair has 0, -1. I need the second number there. So this is -1. Okay, I need the first, since I'm looking for cosine of 3 pi over 2. Now I need the first number. So cosine of 3 pi over 2 is 0. Okay, cosine of 0. So we're right here. That order pair is 1, 0. I need the first number since I'm looking for cosine of 0. So my final answer there is 1. Okay, same thing. Now I'm looking for sine of 0. I need the second number. So sine of 0 is 0. Okay, if we look for 2 pi, well, there's not any difference between cosine of 0 and cosine of 2 pi because you end up at the same ordered pair, 1, 0. So cosine of 2 pi is really the same thing as cosine of 0, which I look for the first number. So that's just going to be 1. Same thing for sine of 2 pi, but now I'm looking for the second number here. So sine of 2 pi would be 0. So that's how you use the unit circle if you're trying to find a quadrantal angle. Remember, a quadrantal angle is either 0, 90, 180, 270, or 360, or 0, pi over 2, pi, 3 pi over 2, and 2 pi if you're talking about radians. Now let's look at Pythagorean identity and how we use the unit circle to get to this identity. So we've got our little angle right here, and we're looking for this point, xy, which we know in the unit circle we call that cosine theta comma sine theta. Now if we take the equation of a circle, which is right here, r squared equals x squared plus y squared. And if we substitute what we know about the unit circle, that r is equal to 1, x is equal to cosine theta, and y is equal to sine of theta, if I substitute that back in to this equation here, then what I'm going to get is this. We're going to have 1 squared is equal to cosine theta squared plus sine of theta squared. Now this is just a notation thing. What you're going to do is you're not going to have cosine theta and then the whole thing squared. You're going to take that 2 and you're going to put it right after the trig function, okay, like you do here. That's just a notation thing. These two things right here mean exactly the same thing. You're going to square cosine of theta. Okay, get rid of all my markings. So once you do that, 1 is equal to cosine squared of theta plus sine squared of theta. That is our Pythagorean identity.